And here's a rigid body problem. Let me adjust this so you can actually see my head. Okay, so for this rigid body problem, we have a ladder leaning up against a wall. A painter is going to climb up the ladder, and we want to figure out the minimum coefficient of friction between the ladder and the ground so the ladder doesn't slide. So here's the problem. We have a 4 meter long, 20 kilogram ladder. It's leaning against the wall, makes a 70-degree angle. An 80 kilogram painter climbs to the top of the ladder, and we want to figure out the coefficient of friction here so the ladder doesn't slide out this way. Now, when we draw force diagrams for these rigid body problems, we can't treat the body as a dot like we've done in other problems. Like if you have a crate or a box or whatever, you can treat it as a dot. But for problems like this, we've got to draw the force diagrams more like this. So here's the ladder, and here's the ground. The ground is going to apply a normal force to the bottom of the ladder. We're going to call that N1. There's also a frictional force between the ground and the ladder, which we labeled F. At the center of gravity of the ladder, the weight force, the weight of the ladder, is pulling it down. At the top of the ladder, the building that it's leaning against is applying a normal force out this way, which we'll call N2. And I put the painter at the top of the ladder so his weight is straight down there. Now, in these problems, we ignore friction between the side of the building and the ladder. We always assume that there's zero friction here. That makes our life a lot easier. Now, in reality, there's going to be some friction, but for these problems, for our purposes, we're pretending that there's no friction between the ladder and the side of the building. So since this ladder is at rest, it's not accelerating, it's not rotating, we know that the net force is zero and the net torque is zero. So that's what we do here. We look at the net forces in the x direction. We say that they're zero, which means that the force to the right, the friction force to the right, minus the normal force to the left have to add up to zero. All right, now we have a cat that's kind of getting in our way here. Let's